Hello friends, welcome to my YouTube channel Raghavendra Mysore. Today we are solving problem number 5 from the unit of triangles of class 10. The question is taken from exercise 6.4 in CBSE textbook and it is taken from exercise 2.4 in Karnataka state textbook. The question is like this: D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. I will repeat the question once again. D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. We need to find the ratios of the areas of those two triangles. They are saying that there is a triangle by name called as triangle ABC. It is having three sides and DEF are the midpoints of that triangle. So we will draw the figure of a triangle by name called as ABC triangle. So I have drawn the figure of triangle ABC. You can observe here triangle ABC, where D is the midpoint of side AB, E is the midpoint of side BC and F is the midpoint of side AC. See, we are going to find out the ratios of the areas of those two triangles by using the midpoint theorem statement. So before that, we will write on the given here. What is given here? They have given the triangle by name called as triangle ABC, where D, E and F are the midpoints of sides AB, BC and CA. This is given. So what we need to prove, what we need to find out, we need to find out that the ratios of the areas of triangles, that is area of triangle DEF, because they are given first DEF triangle, by area of triangle ABC is equal to question mark. We need to find out this one. See, if you carefully observe the figure, D is the midpoint of side AB and F is the midpoint of side AC. So that means D is dividing the length of AB into 2 equal half and F is dividing the length of AC into 2 equal half. What does the midpoint theorem states means, if a line is drawn, if a line divides the two sides of a triangle, the statement of the midpoint theorem states like this, okay? If a line divides the two sides of the triangle in equally, then that line will be parallel to the remaining side of the triangle and it is half of the third side of the triangle. I will repeat the statement once again. If a line divides the two sides of a triangle, then that line, that is DF, is parallel to the remaining side, that is BC, and it is half of the remaining side, that is DF will be half of BC. So if you carefully observe the figure, you can understand DF is parallel to BC. Similarly, DE is parallel to AC and EF is parallel to BC. See here, D is the midpoint of AB, E is the midpoint of BC. So obviously, it is dividing these two sides. Then the remaining, which is the remaining side? That is AC. Therefore, DE is parallel and it is half of AC. So, by using a midpoint theorem, we can write as what? DF is parallel to BC, and DF is parallel to BC means then obviously DF is also parallel to EC as well as BE, correct? This can be written as DF is parallel to EC and DF is parallel to BE. So this is by midpoint theorem. See, I'm just taken one side of the triangle. So if we consider any of the other two sides also, we will be getting the same thing. That is, if I take DE, so DE will be parallel to AC. That also indicates as ED will be parallel to FC. correct? Now, if you carefully observe the figure, this figure, DFBE are parallel, DBEF, it looks like parallelogram. So opposite sides are parallel and they are equal in measurements. So what is another property of parallelogram? We know that the opposite angles of the parallelograms are equal to one another. So opposite angles, angle B and angle F, are opposite angles in the parallelogram. So we can call DBEF is a parallelogram. In this parallelogram, angle B will be equal to angle F. Similarly, if you carefully observe the figure, there is another parallelogram, DECF. See, we can consider this as equation 1, or we will keep as it is. So I am taking the other parallelogram, that is DECF is a parallelogram. In this parallelogram, what we can write? Angle C is equal to angle D, because vertically opposite angles in the parallelograms are equal. So in both the cases, vertically opposite angles. So DECF. So these two angles are equal to one another, and these two angles B and F are equal to one another. If you observe the figure here, D and F angle are present in the triangle of DEF, and B and C are present in the triangle of triangle ABC. So by this we can write, to prove two triangles are congruent, are similar to one another, we need two elements. Already we have taken those two elements. Therefore, triangle ABC similar to triangle DEF by AA criteria. So we can go for the corresponding sides ratio with respect to the area of the similar triangles. The ratios of the areas of the similar triangle is equal to the square of the corresponding sides. By that theorem, we can write area of triangle DEF by area of triangle ABC is equal to DF square by BC square. DF is present in the triangle of DEF and BC is present in the triangle of ABC. But before we complete that one, we need to understand. So DF is equal to what? Half of BC. Not only DF, if you take DE, it is half of AC. If you take EF, it is half of AB. So if DF is half of BC, what I can write? That is, we can write BC is equal to 2 times of DF. I hope that you have understood this particular portion. So in place of BC, I am going to write, so area of triangle DEF by area of triangle ABC is equal to DF square as it is by BC can be written as 2 times 2 into DF square. So this can be written as DF square as it is by 2 square 4 and DF square as it is. DF square get cancels, that is 1 by 4. So the area of DEF by area of triangle ABC is equal to 1 by 4. So 1/4 of the time of the triangles. So whatever the measurement of DEF triangle area is there, the area of triangle ABC will be 4 times of that measurement. So if I want to make it clear, if you imagine the area of triangle DEF is 100 square units, then obviously area of triangle ABC will be 400 square units. So I hope that you have understood this particular problem. If you have liked this video, please give a like to the video, share the video, and don't forget to do a comment. And if you're new to my channel, please do support the channel by subscribing it. Thanks for watching the video.